Gensyn, it sounds like, is specifically for machine learning. And please tell me if I'm getting this wrong. Are there aspects of your protocol that are supportive of machine learning in that way? Is it a package that you're creating for developers to use? How is it different than
Yeah.
maybe a cache where you're renting, the bare metal kind of thing?
So, so I guess to answer the second part of your question, like exactly kind of what is it? It's a protocol which very inexpensively verifies a series of state-dependent graph computations. That's the absolute nuts and bolts way you could describe it. What a neural network is, for the listeners not familiar with machine learning, is basically a series of layers of computations through which data is passed, and then there's a kind of derivative function applied going back across the various layers, multiple hundreds, maybe thousands of times in some cases. The kind of result of that is you basically have to traverse this graph in a state dependent way multiple times. You can use a protocol like a cache for that. I used a cache earlier today. I was playing around with it, define an SDL, deploy it on a GPU, pay for it out the cache wallet, you bid on it. What you kind of don't get there is you don't get a verification system, so you don't know if the person, if the hardware that you're trading it on is necessarily correct. It also uses a kind of reputation system for scoring hardware, and currently there's also a kind of audit functionality where the cache team will audit various devices to make sure they're good. I think a cache is a great protocol. What we do is distinct in the sense that we only do machine learning computation. So we only do those graph computations. Currently, we only do it for training, and we do it at a limited scale. Usually, if you require reputation-based systems, you struggle with scaling because the Byzantine fault tolerance, basically the ability to attack the network using, fake accounts in the civil attack sense, gets too easy. It gets too cheap to do. So we enable that huge scale. And because we're very specialized to just doing the machine learning verification, kind of graph computation, the price is very low as well.
I'd probably just emphasize how important the verification part is. That's the big problem in building anything like this. You can kind of build a marketplace over a resource just by providing the distribution. So providing some way of getting a computation to the device and then getting the results back. But that's only half of the problem. The other half is if I allow this network to get the largest it could possibly be, I will have to allow completely unknown parties to join the network as suppliers. And it's being able to trust those unknown parties that makes this a difficult problem. And verification is just how you do that. Verification of general purpose compute is a really hard problem because there's a lot of things you can do in general purpose compute. It's basically what Ethereum solves, but Ethereum solves it by having a lot of people rerun the computation essentially, which is one way to do it. But for machine learning computations, you don't have that luxury. They're very large. Like Harry said, they're state dependent. They're typically non-deterministic, which means rerunning them doesn't get you the same results, which makes it very, very hard. So you have to find different ways to get around it. But in finding those ways, you can exploit certain things about the type of computation. So you narrow the space by only focusing on machine learning computations, which lets you do things that wouldn't work for general purpose computation, make it more efficient, and then solve the problem just for that. And it's similar to what LivePeer have done for video transcoding. They've gone super specific. There'll be things that they do within the protocol that they couldn't do if they were doing some other computational task. And that's the approach that Gensyn takes. So we only focus on machine learning training itself, so the forward and backward passes of neural networks. But in doing that, we do a lot of matrix multiplications. There's things you can do with those matrix multiplications to verify them quite efficiently that you wouldn't be able to do if you had to call out and do a different operation essentially. And so yeah, I think like you said before, a cache does that general purpose computation and they do the distribution, but then when it comes to verification, I think they sort of pass that off onto somebody else. So the end user is sort of responsible for their own verification, which is an interesting way to do it. But for machine learning specifically, we figure the verification should be handled at the protocol stage so that the user doesn't need to somehow bring lots of kind of ways of checking their own computation. They just want to do the computation.